Hello, and welcome to this clip going through a walkthrough of an applied ion testing question with some tips on perhaps how to analyse and deduce what the question is asking as we go along. So looking at the question, it starts off by saying that B and C are ionic compounds of two different group 1 elements. So we know that if they're in group 1, the elements are going to be +1 in their ions, and therefore we can deduce the mole ratio of the metal to the ion, and once we've worked out what the negative ion is from the ion test observations. And if we can use the observations to work out the identity of the negative ions, then the molar mass of 140 grams per mole can allow us to approximate the identities of the two metals. So starting with the number of marks allocated, there's 5 marks, so you need to allocate your work accordingly and put a reasonable amount of detail into this. So it says use this information and the observations, so that means the observations in the table plus the fact that B and C are both around 140 grams per mole. So it's worth just referring to the periodic table, and I've just sliced out group 1 so we can see the relative atomic masses of the elements there. So the first thing to do is to deal with all the observations from the table. So it says that bubbles with addition of HNO3 for B must mean that it's a carbonate, or it suggests anyway that it's a carbonate, so you just put that down, and then the same for C. The fact that it's a white precipitate with a barium chloride solution would suggest that it's got a sulfate ion in it. Now it's also important to point out that if there is no change for any of the other compounds, so for example HNO3 for C has no change, that must mean that only B contains the carbonate and only C contains the sulfate. So both of those anions are 2- in charge, so you need 2 1+ ions needed to balance that charge in the compound. So the metal, there should be 2 the metal and 1 of the ions, so M2SO4 or M2CO3, M being the metal of course. Now using the molar mass information, you can subtract the molar mass of each ion from 140 grams per mole to get an idea of the contribution to the total, that's your 140, that the metal will make, and then you can try and match it up with an appropriate metal from the group 1 part of the periodic table. So carbonate has a molar mass of 60 grams per mole, so if you take away 60 from 140 you get 80, and as we've already worked out there are 2 metal ions for each formula unit. We divide that by 2 to get 40, and as you can see from the periodic table, 39.1 is very close to 40, so B must be potassium carbonate. Sulfate has a molar mass of 96.1 grams per mole, so doing something similar there leaves us with 43.9, and again dividing that by 2 for the same reason as before, we get 21.95, which is quite close to 23, so therefore C must be sodium sulfate. Okay, and thanks for your time listening to this. Hopefully it's been a reasonably useful run through of how to do a more deductive analytical question like this. Until next time, thank you and see you soon.